Alright, today we're taking a look at I can find the power of a product. We're going to start off by coming up with a nice example for us. We have the quantity 3x all to the second power. We have an entire term here now inside the parentheses. That's what's different here. And we're going to go back to our definition of an exponent to take a look and see if there's some shortcuts or rules that we can use. So we have 3x to the second power. We know that that's the same thing as 3x times 3x. Whenever we take something to an exponent, we're saying take it, multiply it by itself that many times. So 3x all to the second power means take 3x times itself, 3x. We can simplify this just a little bit because we can think of 3 times 3 as really the same thing as 3 to the second power. And we can think of x times x as the same thing as x to the second power, going back to our rules of multiplying when we have exponents in the same base. So essentially, 3x quantity squared becomes 3 squared times x squared. What we've essentially done is taken each of the two components inside the term 3x and taken each of them to the second power. And that can be our third rule. Rule number 3. When taking the power of a product, apply the exponent to each piece of the term. Now let's see what that looks like with the example problems. In question number 1, we have negative 2xy, that entire quantity to the fourth power. So according to our rule number 3, we're going to take each individual piece of that term to the fourth power. We'll start with negative 2. We'll take negative 2 to the fourth power. The next piece of the term is x. We'll take x to the fourth power. And the final piece is the y. We'll take y to the fourth power. The result should be simplified as best it can. In this case, negative 2 to the fourth power. We can actually do that math. If you're going to type this in your calculator, please remember to put parentheses around the negative 2 so that you end up with the correct answer of positive 16. We still have x to the fourth, and we still have y to the fourth. And we know we're done because none of the pieces of this term have the same base. X to the fourth has a base of x. Y to the fourth has a base of y, and then of course we have the constant in the front. None of those match, and therefore we're finished with the simplification process. In problem number 2, we do the same thing. We're going to take each individual piece of the term 3m squared n cubed. We're going to take each piece of it to the fourth power. And we'll start with the 3. We have 3 to the fourth power. Next up, m squared, we'll take that to the fourth power. M squared to the fourth power. And then finally, n cubed to the fourth power. We'll simplify as best we can. 3 to the fourth power is 81. M squared to the fourth power, we have a power raised to a power. Rule number 2 from previous videos tells us that when we have a power raised to a power, we multiply the exponents. So m squared to the fourth becomes m to the 8th, 2 times 4 being 8. And then finally, n cubed to the fourth power, again, a power raised to a power. So 3 times 4 gives us n to the 12th as our answer for number 2. Moving on to number 3, we have x squared, y cubed, z to the fifth power. We'll start with the x squared and have x squared raised to the fifth power. Our rule says to take each individual component of the term and raise it to the fifth power. Y cubed to the fifth power. And finally, z to the first to the fifth power. Remember, if there's no exponent, we assume that that exponent is a 1. Let's finish simplifying using our power to powers rule, rule number 2. X squared to the 5th power is x to the 10th. Y cubed to the 5th power, 3 times 5 is y to the 15th. And z to the 1st to the 5th power, 1 times 5 is z to the 5th. And that's our answer for number 3. Moving on to numbers 4, 5, and 6, same concept. It's just we have to do it twice because there's 2 separate terms being multiplied together. We'll start with 3x squared. We're going to take 3x and multiply and square each part of that term. So we'll take 3 squared. And we'll take x squared, x to the 1st squared, if you will. We'll do it again for the second piece. We have 2x squared all to the 3rd power. So we'll take 2 to the 3rd power. And we'll take x squared to the 3rd power. Now all this stuff is going to be multiplied together. So once we simplify each component, we'll have to simplify the entire expression altogether. Let's start with the piece on the left. 3 squared is 9. X to the 1st squared, we're going to exponents to exponents means we multiply them. X to the 1st squared is x. 1 times 2 is 2, x squared. Moving on to the second piece, 2 cubed is 8. X squared to the 3rd, exponent to exponent, 2 times 3 is x to the 6th. We'll finish the simplification by multiplying 9 times 8, or the 2 constants. That gives us 72. And then x squared times x to the 6th. This is rule number 1. When we multiply things with exponents that have the same base, we add those exponents together. So we end up with x to the 2 plus 6, which is 8, x to the 8th. And that's our answer for number 4. In number 5, we have 4mn, and it's technically all to the 1st power here. Again, if there's no exponent, we assume that the exponent is 1. So we could just say that it's 4 to the 1st, m to the 1st, n to the 1st, or we could just think of it the fact that it's something with an exponent of 1 doesn't actually change the expression itself. Let's do it again for the second piece. We have negative 6 to the 2nd power, m squared to the 2nd power, and finally n cubed to the 2nd power. We'll simplify as best we can. 4 to the 1st, of course, is 4. M to the 1st is m, and n to the 1st is n as well. Negative 6 squared is 36. Again, use parentheses if you're typing that in your calculator. Here we have exponents to exponents. M squared to squared is the same thing. We're going to multiply, so m to the 4th. And n cubed to the 2nd power, we're going to multiply those exponents to get n to the 6th. We're going to finish off by multiplying anything that has a similar base. The constants, of course, 4 times 36. Gives us 144. M to the 1st times m to the 4th. We're going to add those exponents together according to rule number 1 and get m to the 5th. And then n to the 1st times n to the 6th. We're going to add the exponents together. 1 plus 6 gives us n to the 7th as the final answer for number 5. Almost there. Number 6. We'll start with the first expression. 5 to the 3rd power x to the 4th to the 3rd power and y cubed to the 3rd power. We'll do the same thing with the second expression. We've got this negative 1 here, so we'll take negative 1 to the 5th power. We've got x to the 4th to the 5th power. We've got y to the 5th to the 5th power. And finally, we have z to the 5th power. Let's do some simplification. The first expression, 5 cubed, is 125. X to the 4th to the 3rd power, power raised to a power, multiply those exponents. 4 times 3 is x to the 12th. Y cubed, exponent to exponent says multiply, so y to the 9th. We're going to multiply that all together with the second expression. Negative 1 to the 5th power is, of course, negative 1. X to the 4th to the 5th power, multiply the exponents, x to the 20th. Y to the 5th to the 5th power, multiply the exponents, y to the 25th. And finally, z to the 5th. We're going to multiply anything with the same base. So we'll start with the constants. 125 times negative 1 is a negative 125. X to the 12th times x to the 12th times x to the 20th. We're going to add the exponents together. We're multiplying things with exponents that have the same base. So we'll add them together, x to the 32nd. Y to the 9th times y to the 25th, same base, so we'll add them together. Y to the 34th. And then finally z to the 5th at the end. And there's our answer for number 6.